So let's start out talking about enols and enolates. And actually, enols are the word there. Enol is a portmanteau of two names you already know from organic chemistry at this point. En being a carbon-carbon double bond, and ol being an alcohol. So when we have an enol, what we have is a compound of the form like this. Now, enols are related to ketones through a process called tautomerization. So what happens with tautomerization, it's kind of like a blend of, let's say, resonance as well as proton transfer. And tautomerization specifically refers to when we change a molecule by moving a hydrogen. So a ketone would look like this. And so when we tautomerize between the two, what we're doing is we're taking the hydrogen and we're transferring it back and forth between the alcohol and the alkene carbon. Now, traditionally speaking, enols are less stable than the ketone analogs. So if you go back to synthesis of alcohols from alkynes, what you'll see is that when we add water, when we do water addition across an alkyne, we end up with the ketone, not the alcohol. And the reason being is that we form an enol. But there are notable exceptions to this, the big one being phenol. So phenol is an enol, but it's a stable enol. And the reason why it's stable is that if we had this double bond, we end up creating an aromatic system. So while this is generally speaking, if there's some reason why this double bond is involved in an aromatic system, we're more likely to produce the enol. Now, to tautomerize between the two, we can either do this through a base catalyzed mechanism or an acid catalyzed mechanism. So in the acid catalyzed mechanism, what ends up happening is that we protonate the ketone first. So we add an OH, we add an H, that kicks the bond down and that abstracts the hydrogen back out. In the base catalyzed version, we actually remove the hydrogen from the carbon, which ends up moving this bond down to give us the alkoxide, and the alkoxide here would protonate. Now, I said alkoxide, that's actually not that's the analog of what you're used to thinking of. So under the base catalyzed reaction, we go through this O negative intermediate. This is going to be our enolate. So when we say enolates, we are saying an enol with the hydrogen removed from the OH, the alcohol group, to give us the enolate ion. So this is what enols are. Enols are an alcohol group adjacent to a double bond. And when we say adjacent, we mean that alcohol is hanging onto a carbon. It is related to the ketone through the tautomerization, so exchange of hydrogen between the adjacent alpha carbon, this carbon here, hydrogen transfer between this carbon and the oxygen. We can do this under acid and base catalyzed conditions. We're going to talk about when that makes a big difference, but it can be done underneath both conditions. So this is here your summary of enols and enolates. Let's talk a little bit more now about their chemistry and why this is important.